The paradox of parallax. So, what is parallax? Parallax, the effect whereby the position or direction of an object appears to differ when viewed from different positions, ergo through the viewfinder and the lens of a camera. So let's explore that. So here we have a twin lens reflex. This is one of the cameras from my collection. I love collecting old cameras. And this camera has a two lens system. And the top lens is your viewing lens. The bottom lens is your picture taking lens. So the top lens will view your subject at a slightly different point of view, a little bit higher, and the picture taking lens will actually take the picture that you view at a lower point of view. Now, this is okay at long distances, like if you're doing a landscape. But if you're doing a portrait or close-up work, this becomes a problem, and that's called parallax. You have to compensate for that. So that's what it means in the photography world. So let's see what it means in the astronomy world. The angular amount of parallax in a particular case, especially that of a star viewed from different points in the Earth's orbit. So, so when you have stars that are trillions of miles apart, uh, uh, over a course of years, centuries actually, you can actually see, or you should see, different constellations due to the amount of time it took for, for the Earth to rotate and travel through the cosmos and that sort of thing. But due to the vast differences between the stars, the parallax is unperceivable. So according to science, you really can't see the parallax because of those vast differences. Well, let's explore that concept. All right, so let's look at some distances and speeds. The Earth's orbit around the sun is approximately 70,000 miles per hour. Earth at the equator moves at roughly 1,000 miles per hour. The solar system is traveling at an average speed of 514,000 miles per hour around the galactic center. The Milky Way travels at 1.34 million miles per hour in the direction of the constellation Hydra. The universe rate of expansion increases approximately 42 miles per second. Okay, so we're looking at all these incredible speeds and all these stellar bodies moving at completely different directions. So it's kind of chaotic out there, all right? So this is the type of environment that we're dealing with. Vast differences, huge speeds, and completely different trajectories. So let's move on. All right, let's explore that down here on Earth, okay? So what we have here is a video that I shot. My wife and I were driving downtown, and you can see that the buildings in downtown are moving a lot slower than the street signs that are whizzing by, and the freeway lines are moving even faster. So the objects closest to us are moving past us pretty quickly, but the objects further away, like the arena and some of these buildings over here, are moving pretty slowly based on their relative position to us. That's called parallax. All right, let's move on. So now you see this fence is moving so fast. Try to focus your eye. I used to do that when I was a kid. I tried to focus on one pole of the fence that made me dizzy. So the fence is moving fast. You see the windmills here are taking their time. They're meandering by. The trees in the background are moving really slowly. That's parallax. where the objects closest to you are moving past you faster than the objects furthest away. You experience this all the time. Look at these hills back here. They're moving really slow. Okay, let's move on to this grassy hill here, this grassy field, I should say. Look at all this tall grass. It's really moving fast. Are you starting to see a trend here? Okay, the grass is moving really fast, and then you have the trees way in the background here. They barely look like they're moving at all. So, but then you see this bank of trees here. They're moving a lot faster than the trees really far out. Okay, let's look at this video here. You see the bushes and the weeds and all that stuff. They're moving fast. You see this bank of trees here. It's moving kind of slow. That tree whizzed by. These trees, the houses, they're moving really quickly. But as you can see the background, it's moving, but really slow. And the further you go back, even this little hill back here, it's moving. I'm gonna put my pointer on it. Okay, look at that. It just moved past my pointer, but it did move. That's the point. Even though parallax is at work here, the background is still moving. Okay, let's take that electric pole. Up, yep, it's gone. It moved off my pointer. All right, so it's still moving. No matter how far it is, you will detect parallax. Distance does not cancel parallax. It will slow it down. The perception of movement will slow down, but it will not stop it. All right, now this is a really good one here. This fence is moving, man. It's moving really fast. But look at this landmass out here. We're going to cross a boat. You see that boat? That boat's moving at a pretty good clip. But excuse my shakiness. But you see those hills in the background there? They're moving pretty slowly. And look at the clouds. I'm going to put my pointer on a cloud here. Oh, I can't do that. Oh, wait, there it is. Okay. So, oh, video stop. But you saw my point. Okay. Um, it moved pretty quickly up front, and the background moved pretty slowly, and the clouds were moving pretty slowly as well because they were further away from my point of view. That's parallax. So, what do we have here? Once again, modern science attached a legitimate phenomenon to an illegitimate and unprovable theory. So basically what they did was they took a legitimate phenomenon called parallax. We experience it every day, professionally, and just in normal life, we experience parallax. But what science has done is actually taken a legitimate phenomenon and attached it to a theory that has been completely unproven. So, what are we looking at here? The only way to change the repeatable, observable laws of physics is to introduce a new and alien environment. And that environment would be space. Yes, when you add space into the equation, the phenomenon we call parallax changes completely. Because when you take space, which is an unproven concept, when you take space and add it into the equation, then basically you can say anything you like. Okay, you can change the rules and change the laws that we are familiar with on a day-to-day basis and make them totally different because this construct called space is unsubstantiated, unproven, and you can basically do anything you like there. So, what's my conclusion? My conclusion is observe the phenomenon, observe the rules that you live by every day as far as creation is concerned. What you see with your eyes, what you perceive with your mind actually is legitimate. Your senses are valuable. You experience parallax on a daily basis. You can trust that experience. All right. So when someone comes up with a new environment like this thing called space, when someone comes up with a new environment and add it to the experience that you live every day, then there's only one thing that you have to do. Don't accept, verify.